है. Just remind me at the start of lecture. Maybe I forgot. So many things are there in my mind. Okay. Now these moments now they can be shown like this and like this. Okay. Now see here whatever value you got. What is value? 15 point something. 15 point something. I don't. 15.8. You have to give unit also now. What is the moment unit? It is a force into distance. So what is the I think my so force is a Newton and distance will be according to your given choice. So it will be centimeter. So Newton centimeter. No, not Newton meter. Just see your distance, whatever you are given, they are in centimeter. Everywhere 3 centimeter, 2.08 centimeter. So steam is not acting okay. So Newton centimeter, remember. Okay. If this distance are in meter, it will be Newton meter. Now our moments some problem you will get different kind of moment. Okay. So let's do some addition of moments. Simple problem I will give. You have to give me answer, huh, everyone. I know you understood this concept, so it will be easy for you to get answer. So one moment and two couples are given, and they're asking you to get a final value of moment. So couple is a special form of moment, and how to find a value or convert into moment? It's very simple. Just see here. Draw same diagram. It can be anything, huh? Not same diagram. Now, if you see how this couple are moving, they are in Which direction? Clockwise or anti-clockwise? Clockwise direction. Similarly, this anti-clockwise direction. So we can draw here this moment as what is the, if you want to convert couple into moment, what will be the value? 50 into per distance between those two forces. So 50 into 2, 100. 100 Newton meter. Already here 150 is there na? 150 Newton meter. And last one is the 10 into 4, that is 40 Newton meter. So we got all three moment. Now it is easy to add, just positive, negative, positive, negative. So moments you can add directly. There will be, because moment is a free vector, so no need to take any at any point anywhere because force is not given. So first we'll take 100 Newton positive because it is in clockwise direction. Then 150 positive clockwise direction minus 40. क्या हो रहा है? 100 plus 150 minus 40. So what is the answer? Yes. So this is how we can represent our moments. Okay. So we can do addition of moments. We understood this. Let's go to the resultant of non-concurrent force system. Next chapter. Chapter, I am not saying module. Just give me a second. Okay. So earlier we solve all problems to find out summation fx and summation fy for concurrent system, means those forces starting from some points at center, right? Now what we are going to do is we are going to get it for non-concurrent force system. How it will be? Just consider one body on which these forces are acting. So F1, F2, F3. Okay. So this F1, F2, and F3 are forces acting on a body. Let's consider this is as a point O. So earlier I explained you how to transfer the force, right now? How to transfer the force. Once whenever you transfer the force, it will create a moment. Do you remember? Like this I have shown last lecture. One force is acting on this bar. So if I want to know the what, I want to transfer this force from this point A to point B. What I have to do? I have to draw a force here, and then in which direction it is moving. It is moving in clockwise direction. So I have to add a moment. What will be this force into this distance between these 2 points? Is x. So that will be the final answer. So what you will get? One force and one moment. F into x. Okay. How to transfer one force from one point to other point is very simple. Only you have to take a force at that point and draw a moment that is equal to force into the distance between the 2 points. Okay. So this is how we transfer these forces from one point to other point. Now we are going to use similar pattern to get a resultant of non-concurrent force system. Earlier we used to find out for concurrent force system. Now we are going to find out for non-concurrent force system. Okay. So for non-concurrent force system, first important thing is now all these forces are passing. If you draw their, okay, one more force I will add. Otherwise, you know that if three forces are acting on one body, they must be concurrent. Okay, if you see all these forces, they are not passing through one point, but their line of action. I will draw line of action of every force. One by one, we'll add. Draw. This is line of action of F2. This is line of action of F1. This is line of action of F3. This is line of action of F. So if you see these forces, their line of action doesn't meet at one point. So this force system we can say non-concurrent force system. What? we can say it as a non-concurrent force system. Now, how to solve such problem? It's very easy. What you have to do is transfer the forces, like from this F2 to this distance you have to find out, that is x. Then you can transfer this force here F2, and now it will be in which direction? So in anti-clockwise direction, moment will come. F into x. Two forces are done. Next, one by one we'll do. Now, if you want to transfer this F3 force, it is not passing through center. So what is the distance between these two? Y. So it will be where, in which direction? Clockwise direction. So automatically F1, F2, F3, and now it will be summation of moments. So I don't know which direction. Just consider any direction. If it is positive, then answer is correct. If it is negative, then summation of moment at point O. And last one is a F4. So what you have to do is you have to take a moment of all these forces F2, F3, F4, avoid point O. If F1 also passing through, if it is not passing through, then you have to take a moment of all forces and take a moment at that point. Have you understood what you have to do? Like non-concurrent force system is given. F1, F2, F3, F4. First, convert it into concurrent system. So this is the point. So now it has become concurrent system. Only thing is it will come one moment. You can consider any direction, clockwise or direction, summation of moment of all forces about point O, this point O, this point O. You have to take. It may be positive, it may be negative. If positive, it will be clockwise direction. If negative, it anti-clockwise. At start, you can't consider anything. That's why. Now next procedure is same. You have to find out summation fx, summation fy, and get a resultant. Understood? You understood this? This is for non-concurrent force system. Now x and y intersect. X and y intersect. What is this x and y intersect? I'll tell you. Now in earlier problem, you will get resultant at point O. but there will be a moment acting on that point, right? Summation of moment. So what you can do, earlier what we do, one force we can convert into moment. How? If we transfer that force, then it will become a moment. So we can convert a moment into force also. F into D. So it is in which direction? Clockwise direction. So force should be on which side? This side. From how much distance? D. So F into D. If we anti-clockwise, F into X. So from here at X distance, there is a force acting like this. Okay. So we can convert moment into force system also. The question is where does the resultant acting? Because earlier it will be acting at the point of intersection of all forces. But here it will be not the same. Okay. So what will be the, we'll see after a 5 minute break. We'll take a 5 minute break, 10 minute break. So we'll come back at 10. Continuous online, I know it will be very difficult for you also. So let's take a 10 minute break and let's join again at 10. Perfect. Okay. Take care. हो येतो येतो. हो हे लेक्चर झालं की येतो तिकडे. नितीन सर आलेत काय? आज येणार आहेत काय? अरे बापरे. त्यांना सगळं माहित असतं ना बारीक बारीक. फोन करून विचारतो मग मी. हो तेच तेच. Okay, so we will now start with next point, that is x and y intercept. Now earlier it is like we know that our resultant in concurrent force system, we know that where is our resultant. But in non-concurrent force system, we never know what is the position of resultant from some point, right? So if you want to find out some position of that resultant from some point, what you have to do is you have to find out x and y intercept. Okay. So how to find out any force x and y intercept? It is very easy. Just see here. Just consider these two axes, okay, and consider one point O. Let R be the force whose uh, distance is B from point O. Okay. Now we can take a moment. What will be the moment? Moment is equal to summation of moment due to R is equal to R into D. Summation of moment is equal to that force R into the distance D. Okay. Or we can write this, if we go further, it will intercept it somewhere at 2 points, one on x-axis, one on y-axis. Okay. Let's say this is having two component, summation of fx, summation of fy. Why? Because it is directing towards which quadrant? Fourth quadrant. Now, if this force, if you consider, it is intercepting at this point in x-axis, which is at a distance of x. Okay, so we can say summation fi. You can show anywhere, you know that, right? And same resultant, this force, we can show summation fx along the line of action. It's a distance of y. So this x and y is called as a, it's called as a what? Component. Sorry, summation fx and summation fy are called as a component of force R, and x and y are called as a intercept at x-axis and at y-axis. Okay, so one by one we will do. Let's find out. One by one we will do. We'll first consider along x-axis. Okay, so this is the resultant. If we continue its line of action, then we will get two component summation fx summation fy. Let it is at a distance of x. So what will be its moment? Summation of moment is equal to R result force into D, or according to Varigno's theorem, it will be the summation of moments due to its components. So what are the components? Summation fx. Okay, now tell me one question to all of you. While doing this, I understood, I forgot to tell you. This force F passes through this point O. What will be its moment? What is moment definition? Force into perpendicular distance. So here, if force passing through that point only, then there will be no moment. That means moment is equal to 0. Similarly, here in this case also, if you see this summation of force x direction, it is passing through point O. So summation fx into 0, because there is no perpendicular distance. So moment is 0. And plus summation of fy into x. So what is x? X is equal to summation of moment about point O divided by summation of forces in y directions. Similarly, you can prove that and calculate y-intercept as summation of moment at point O divided by summation of forces x. I know many people, this is bouncer for them. What happened? They don't know what I did just now. They can't understand. I know. But don't worry, when we'll go for a numerical or problem, you will easily understand what actually I was doing. Just remember, x-intercept is equal to summation of moment divided by summation of forces in y direction, and y-intercept is equal to summation of moment about that point divided by summation of forces in x direction. Okay, please note down this formula in your notebook. Have you noted down? So let's go for one numerical, simple numerical of non-concurrent system now. It will be same, solving will be same. Only thing is final step of getting resultant will be, position of resultant will be different. Determine, just give me a second. This app is acting weird. So I'll close this app and I will open again. Okay. Determine the resultant as shown in figure. So some force system is given. You can draw a diagram with me. One point five, 1.5, 3, 2. These are the distance. Huh? So how to go with such problem, non-concurrent force system? I'll explain it. First, we'll solve this problem. Then you can go for another problem. Okay. What I will do is I'll change some values. Otherwise, it will be same in your notes. Blue color is nothing but a distance. Don't worry about it. So how many forces acting on this bar? Total three forces are acting. One is a 4,000 Newton, another is a 5,000 Newton, and third is a 60 kilonewton. Okay. So always follow the same procedure. Check whether all forces along the axis, which axis you consider, okay, global axis. So any force is there which is at angle, yes. So 60 Newton, kilonewton is force which is at a 40-degree with horizontal. It is directed towards which quadrant? It is directed towards the third quadrant. So 60. Automatically, or you may get confused as from where it is acting. So what I will do it. When bar will come na, okay, no problem. Let's do it like this only. Keep it as 60 sine 40 degree and 60 cos 40 degree. Simple. You have done 1,000 times, right? 60. So now all forces are there in x and y direction. First step, always they are asking you to find out resultant. So automatically first step is summation f into x is equal to, so all forces in x direction. So how many forces are there in x direction? Only one force is there, that is 60. Now see, it is in kilonewton and all other forces are in newton. So there should be homogeneity in your units. So automatically 60 kilo means 1,000. So 10 raised to 3. Okay. Cos 40c. Only this force is there which is horizontal. Any other force is there which is horizontal? No. Now let's do summation of forces in y direction. Summation of forces in y direction. So it will be like all are negative, minus 400 minus 4,000 minus, क्या हो रहा है, minus of 4,000 down, minus of 5,000 down, and minus of 6,000, 60,000, not 6,000, 60,000. Okay, what we can do? Okay, kilonewton. Let's keep it as it is. 60 into 10 raised to 3 sine 40. So from here we will get summation fx and summation fy. Once you get summation fx and summation fy, next phase is very simple. Directly you can get a resultant. Okay. So find out first value and give me value. Fast. Do it fast. This is the problem. Yes. Yeah, apex also should be in minus. Yes, yes. Good. Apex should be in minus. Chinmay and Aditi, why your answers are different? Someone is 47,000 and someone is 45,000. It's simple. 60,000 cost 40. Okay, summation fx is correct. 45962. Okay. And summation fy Aditi you gave. Okay, no problem. So what we understand from here is summation fx is negative and summation fy also negative. So it will be in which quadrant now? Resultant will be in third quadrant. Again, what will be its angle? Alpha. So tan alpha is equal to summation of fy. Same, we are done this. Get alpha. Till this point, your numerical will be same. Okay. After this, because you have to find out the position. Earlier, we know that resultant will be acting at that point because all forces are concurrent, means acting at a point or passing through one point, right? Here, these forces are non-concurrent. So we have to find out this x-intercept and y-intercept. Find out x and y-intercept. Now, if you see, this is a one problem where there will be no y-intercept, only x-intercept will be there. So how to find out x-intercept? What is the formula x-intercept? Just now I have given. What was that formula? Do you remember? X is equal to summation of moment divided by summation of forces in y direction. So you have to take a moment about one point. So which point we'll consider? We'll consider this point as a point E. Any point you consider. From here, you can find out a position of from here. What will be the distance of intercept? So first, what you have to do? You have to take a moment. Let's do it. I'll draw it again here. Mhm. 4,000, 5,000. Okay, now we have to find out moment about this point. We consider this point as A. What are the distance? 2, 2, 2, 3. Let's start taking moment about point A. So moment about point A is very simple. 4,000 into 2. How much perpendicular distance between 4,000 and this? So how to get draw a line. or line of action parallel to the point A. So you will get a perpendicular distance between 4000 Newton and point A, that is 2. So magnitude 4000 multiplied by 2. Now they are moving in clockwise direction, so it's positive. Next, again 5000 into, now you have to see how much distance it is. Is at a distance of 4 from point A. So it is 5000 into 4. It is also in clockwise direction. Now here, when such force is given, what you have to do is you have to consider this component at a point of at a 60,000 sine 40 60. Just wait for a second, I'll take this call. Nowadays, customer care number also gets some fancy number like mobile number. Okay, so this is our case. So last, remember when force is at a point at an angle, so you have to draw this component along the line of that beam. So automatically the 6000 cos 40 is passing through point A, so it won't have any moment. So remaining will be this 6000 sine 40. How much distance it is from? Let's find out. It is at a distance of 6. So it is in which direction? Again clockwise direction. So plus 60,000 sine 40, that is the force into distance as 6. So if you calculate all those things, you will get moment about point A. Then you can easily get a x intercept as What is that formula? I forgot. Can you help me? Yes, summation of moment divided by summation of forces in which direction now? See, x intercept means y direction. So get value of x. Everyone, please solve it. Everyone, please solve this and give me answer. Yes, so 5.453. So it is at a distance of 5.453 from A. Minus, so it will be plus, then it will be on other side minus B. Yes, it is a minus, so it will be after point A, other side. So few problems you can solve on this type of getting x-intercept and y-intercept of. So one more problem we'll solve in class so that everyone will understand. Now let's go to the next important topic where everyone will get out mark. Everyone from Ambani to Fakir, everyone will get out mark here. From Einstein to our so what is that topic name is force system application to beam. Okay, so before going for what is mean by beam, I want to share some important thing, that is types of support. Then we'll see what is mean by beam, and then we'll go for problems. Okay, so first, types of support. So first is a smooth support. So first is a smooth support. Smooth support means what? The supported body is not rough, it is well finished, so it is not applying any friction. Will when we study friction, you will understand what is meant by smooth support. So we already studied smooth support like this problem. So we solve such problem number of times. So these supports are called as the smooth supports, and if we remove the support, we get a reaction towards the body perpendicular to the surface. So this is called as a smooth support. What I will do, these things now need to understand perfectly to get out of our marks. If we go for online lectures for this, I will create a confusion. No problem. We'll go through it one by one, and tomorrow we'll see in detail. Okay. Next one is a roller support. So what is mean by roller support? A roller support is equivalent to frictionless support. It can only exert a force that is perpendicular to the supporting surface. Okay, that means I'll show you how. Have you played this game, or this will be toy for you? I don't think so. You are from digital world. I don't know whether you played or not, but we used to play. One small wheel is attached to a stick. A small wheel is attached, okay, to a stick, and we used to play with it. Okay, so this is called as a roller support. Why? Because this stick can move anywhere. You can move upward, you can go forward, you can come backward. Okay, so all this thing you can do using this support. So this is called as a roller support. Another Now, if I want to show this roller support, how it will be? Free body diagram. Vertical force only. Only one support is there. Next diagram. This is also roller support. And if we remove this support, then reaction will be like this. Okay. So this is called as a roller support. One by one, we are seeing, looking out for what types of supports are there in our system. Then next is a hinge support or pin support. Third, hinge or pin support. Okay? Simple thing. So how you open and close door? Any mechanism is there in your door? Any door? What is you what you can say connection link between door and frame or your wall? What is that? Tell me. Fast. What is it? It is hinge. Right now, hinges are attached so that you can close and open door. So, yes. So, what we understand from here that the hinge support allows free rotation about pin end, but it does not allow linear displacement of that end. That means, can you move this door in this direction or in this direction? No. Only you can rotate this door or open or close door about this pin point, right? So it only have rotation. It doesn't have linear displacement. Okay. And I don't worry, I will explain again this in class. Last one is a fixed support. So fixed support means what? So you can't move this body is inside, huh? Inside the wall. So you can't move body in X direction, Y direction, or you can't rotate also. Okay. So automatically this is called as a built-in or fixed support. Okay. Then we have another things also. So that I will explain tomorrow, like types of beams, then types of loading, Then we'll start with beam problem. Then our first model will be over. And we have friction and center of gravity in second. So that is all about today's lecture. I think it is continuous 150 minutes. I think it is more than enough for you and for me also. So everyone, I will try to upload attendance assignment today, and I will give. Don't worry, I will give enough time to you to solve it. If you have any doubt, you can come to me at any time. Till that point, take care, stay safe.
Sir,
Yeah,
are you free in the
I'm
morning,
there.
9 to 11 tomorrow?
When? Uh,
Tomorrow, 9 to
tomorrow? No, no. Tomorrow problem is that I'm full busy. Tuesday, Wednesday, I'm full free. I don't have any lecture. Yeah, Tuesday is full time. Okay, chalo. Take care. We'll
Thank you, sir.
meet tomorrow.